Hello, welcome to my mathematics revision session. So this is my revision session where we actually solve an exam question from ECZ past papers, and we have actually picked one question which is coming from circle theorems. All right. So I want you to prepare your pen and paper so that you can take notes. Okay, so let's get started. So here's the question that actually came in one of the papers. Okay, I want you to pay extra attention as we are going to solve this question together. All right, so let's get started. The question reads, in the diagram below, O is the center of the circle ABC, ABC, and D are points on the circumference. So A, B, C, and D are points on the circumference. Okay, AD produced meets, which is AD produced meets the line from C, all right, C at E, such that CD is equal to DE, and angle AOC is equal to 120, the angle at the center. All right, so before you actually start solving such questions on circle theory, or rather properties of a circle, you must understand that these calculations are governed by theorems. So you also must apply those theorems accurately so that you get the full marks here, here, and there. Okay, so we are taught to find ADC. Okay, we're taught to find ADC. So how do you go about it? Okay, let me just write here solutions. Or let me use my blue pen. Okay, right here solutions. Okay, so we are taught to find angle ADC. Okay, so here you actually know that we're actually taught to find the angle ADC, this angle here. And to find this, you must understand one theorem which says the angle at the center is twice the angle at the circumference. So this is the theorem you apply here. Okay, so the angle at the center is twice the angle at the circumference subtended by the same angle. Okay, so we know that AOC is 120 at the center, all right, and ADC, okay, at the circumference. So this is at the circumference. So our solution will be like this. Okay, so it's 1 equals to 1 over 2, all right, AOC, okay, which is also equals to 120 over 2, 22 into 120, 60 degrees. Okay, so this is what the theorem states. It states the angle at the center here, the center, is twice the angle at the circumference. In other words, for you to actually get this angle, okay, for you to actually get this angle, you must actually divide the angle at the center for you to get it. And if you want to get this angle, in case the examiner hasn't given you the angle here, you have to multiply this angle twice to get the angle at the center. So this is how you solve this question. So we have actually applied the theorem here. Okay, we can say angle at the center, angle at the center theorem. Okay, so here you have your mark, which is 60. You have your mark, which is 1. Okay, and our answer ADC, the angle here, ADC, the angle here is 60. Okay, so here our angle is 60. Okay, we continue. B, the question is calculate ABC. ABC, this angle here, ABC. Now, what theorem are we applying here? What theorem are we applying here? Okay, so let me just write the solution for B here. Let me just say B, and we are told to find ABC. Okay, ABC. Sorry about that. ABC. Okay, so in order for you to actually solve this question, you must understand that we are actually applying the cyclic quadrilateral theorem here. Okay, so you can see from our question that ABC is actually opposite to ADC. Okay, and you can see again that A, B, C, and D is a cyclic quadrilateral. This one is a cyclic quadrilateral. A, B, C, D is a cyclic quadrilateral. And opposite angles in a cyclic quadrilateral are supplementary. They actually add up to 180. So what do we mean by they add up to 180? What we mean is this. Okay? What we mean is this. We are saying A, B, C plus ADC. Remember the ADC we found here? We found 60, and you can see that it's actually opposite. It's opposite to ABC. ABC is opposite to ADC, and here we have our 60 degrees. Okay, so in order for us to find ABC, we must understand that opposite angles in a cyclic quadrilateral are supplementary. In other words, they add up to 180. Okay, so here we can say 180, they add up to 180, meaning when we find the missing angle, that missing angle, when added to the opposite angle, we have to get 180. That is what it means they add up to 180, or they're supplementary. Okay, so this is how you go about it. So you say ABC is equal to 180 degrees, okay, minus ADC. Okay, what do you get? Here you get, okay, we have 180 minus 60 degrees. The ADC, the one that we found there, and our final answer will be equal to 120 degrees. Okay, let me just write this properly. 120 degrees. So the second theorem we have applied here is the cyclic quadrilateral theorem, and it states that opposite angles in a cyclic quadrilateral are supplementary. They actually add up to 180. Okay, so if you want to get all those marks, you show the examiner the theorem you have actually applied here. So you say cyclic quadrilateral theorem. Okay, opposite what? Opposite angles add up to 180. Okay, you get your 4 marks. This is how you solve such questions. You make sure that you apply each theorem on each question you are solving and show the examiner the theorem you have actually applied. This shows that you understand the question and you get 4 marks. Okay, so let's solve our last question, which is calculate CDE. Let me just zoom a bit here. Okay, so we're calculating DEC. DEC. Okay, so make sure that you also pay attention here, DEC. All right, so for us to actually find DEC, we must understand certain theorems, or rather rules, that actually apply here. Okay, we have got our exterior angle here, which is ADC. Okay, and for us to find the DEC, or which this angle at E, we must understand that this angle here, or rather from CD, okay, you see that we have this, and you know that this is an isosceles triangle, or rather angle. Okay, so this is an isosceles triangle, which means this side and that side, they must be equal. And the other thing that you need to know is that this angle, the exterior angle that we got, the ADC angle, actually shows us that the sum of two angles here and here must equal the angle at here. In other words, you must find the missing angles at DCE here and DEC, and when we add these angles, we must get this angle, which is 60. All right, so what theorem are we applying here? So we're applying the angle in the straight line and sum of the sum of the interior angles, which means when we add these two angles, we must get that angle. But for us to find these two angles, we must apply the theorem. Okay, so now let me write the answer, or rather C here. So let me use the other pen, the blue pen. Okay, so what are we finding? Let me zoom out a bit. What are we finding? This DEC. Okay, so we are finding DEC. Okay, if you have gotten what I've explained here, you understand the steps that I'm going to use now. Okay, since DE, okay, we know that CD, I mean, is equal to DE. Okay, you see there in our question, CD is equal to DE. Okay, there's CD. CD is equal to DE. This is an isosceles triangle. Okay, and what else do you see there? So you must also understand that the sum of angles in any triangle add up to what? To 180. So CDE is part of a straight line with 120. Okay, it's part of a straight line with 120, and our solution will look like this. Okay, so since CDE and DE are equal, okay, so we can write here DCE is equal to 180 minus 120. Okay, what do we get? We get a 60 degrees. So DEC 60 degrees. And now we don't just end here. Remember that we have two base angles, and these two base angles are equal, so each one should be halved. Okay, we got our DEC. For us to get our DEC here, or rather the angle at here at this part, okay, we know that these two angles must add up to the angle there, so this cannot be 60, right? And because of the two base angles, which are equal, each one is half this 60. So we say over 2. Okay, over 2. And when we divide 2 into 60, what do we get? We get 30 degrees. So our DEC is equal to 30 degrees. So here we have our 30 degrees, and there 30 degrees. And when we add these two angles, we're going to get the exterior angle here, which is 60. Okay, so now what theorem have we applied here? We have applied angles in a straight line. Okay, you can write there. Angles in a straight line. Angles in a straight line. Angles in a straight line. And sum, you see we have added two angles. And sum of the interior what? Interior angles. Okay, you see we have added two interior angles on the base, right, of the two base angles, right, and we got 60 there. And you must remember one point here, CDE. Okay, remember this, CDE is part of a straight line angle, which is 120. Okay, so the remaining angle in the triangle is 180 minus 120, which is 60, the one that we got. Okay, the one that we got, 180. Okay, so here 180 minus 120. Okay, and then we divided the two. We divided 2 into 60. Why did we divide 2 into 60? Because these two angles are the same. They're the same, and we need each one is half of 60. Okay, each one is half of 60, and we get 30 for each. This 30 for each, for us to actually get the sum of the other angle on top there. Okay, so basically this is what you need, or what you need to apply to actually solve such a question. Understand the circle theorem behind the question and apply it, and remember to show the examiner what kind of circle theorem you have applied. You're going to get full marks. Okay, so we have looked at the first ABC, and we got our angle 60. We've also did we solved ABC, we got our angle 120. Okay, all right, which is cyclic quadrilateral theorem. Opposite angles add up to 180. We have applied here, and I've mentioned that what we mean by opposite angles add up to 180, I've explained here. You form an equation, and the number or the missing angle that you're going to find, when you add it back to the opposite angle, you have to get the 180, because cyclic quadrilateral theorem states that opposite angles add up to 180, not more than that. Very important. And then C, we have applied the straight line angles and sum of the interior angles. Right, we have subtracted and then divided 2 into 60 to get our two angles on the isosceles triangle. All right, so that when we add two angles, which is the sum of the interior angles, we get the 60, which is the we can call it the exterior angle. Okay, so basically this is the end of our revision session. We are still revising, and make sure that you are part of this session. Thank you so much for being part of this revision session. This has been Tutor Be Smart. See you in my next revision session. It is bye for now.